Yeah, I started recording now. So that is a question. Like, if you have any questions, please ask me, or if you have any concerns, please let me know, so that we can take care of it going forward. Okay. One concern was forgetting to record the session, and if you have any concerns, you can always write an email. Okay, you can always write emails to, or you can email intuition.javatraining@gmail with your questions or any concerns if you have any on any of these sessions. Okay, so we'll try to address those things. Okay, okay. Let us start this session. Today we'll be talking about the operators in depth. Okay, so we'll be seeing what are the different operators that are available in Java, and other things that are related to these operators. Okay, so specifically we'll discuss about the arithmetic operators, logical operators, relational operators, short circuit operators, and bitwise operators are also there. And then finally we will discuss about the operator precedence. Okay, so here I just wanted to discuss bitwise operators in next session. It is you need to know a bit of some how logic works in Java. Okay, logic in the sense like if you have these things, logical operators, right, and or and not operators and XOR operators and all. Okay, how as you know, all these things like all numeric data types, right, integer, floating point, all those things are signed in Java. In the sense like you have you can all are signed irrespective of whether you want it or not. They are all signed numbers. Okay, you can have either positive number or negative number. Okay, how they are stored in or how they are how negative numbers are operated in Java. Okay, how negative numbers are kind of like processed in Java. That is what we need to know. There is something called as 2's complement. Okay, so all those things we need to know before understanding bitwise operators. So that I will try to explain it before we start bitwise operators. That is why I will take that particular operators, that is bitwise operators, in the next session instead of trying to cover in this session. Okay. So in the last session, last few sessions actually, we try to understand what are type conversions and typecasting, different types of conversions, what is automatic type conversion, narrowing conversion, truncations, and promotions, type promotions. When we are dealing with the expressions, how type gets promoted to respective types, and we have seen the rules for automatic type conversions. That is kind of like done by Java, and we have seen arrays, single and multi-dimensional arrays. I had given few exercises. Did anyone try to do those exercises on single dimensional and multi-dimensional arrays, like matrices, part, and sorting, all those things? Did anyone try to do those things? It is very important that we try to do those things, because that will give that will kind of like make your knowledge strong, and it gives you kind of feel that you are comfortable with whatever we have learned. Good, Ari. Yeah. Yeah, Muhammad Atif also. Cool. But I would strongly suggest all of you to try things. One important thing is it took more time to get executed. Yeah, Hari. I'll unmute you. Yeah, so you're telling something like it took some more time to get executed. What does that mean? Can you please explain? Yeah, Hari, I have unmuted you. You can talk.
1 second. Is it okay? Am I audible?
Yeah.
Yeah, there were some mistakes. I mailed you that text also. I mean, my code also.
Okay, okay,
Finally, I executed now. I just tried now.
okay,
I
cool.
got
Yeah,
executed.
got it. Yeah, that is what I want all of you to do. Coding, we will start making syntax errors and all. Okay, so when we make syntax errors, we will try to understand what exactly is going on, where exactly we are making mistakes. Okay, so we will try to resolve all those mistakes, syntax errors, compile time errors, all those things. Okay, so when we start programming, that is when initially we will have a lot of errors, and slowly, right, we will start fixing those errors. Once you start fixing those errors, those things become second nature to you, and you'll stop making those errors. Okay, so that is why I encourage each and everyone to, even if you have, even if you want to code a single line of statement, right, go ahead and try to write program, execute it. Okay, by that itself you will get so much of knowledge, and common errors, right, you get you stop making those errors, and also you get familiar with the Java syntax. Okay, so that is why please try practicing each and everything. Okay, that's what I want all of you to do. And I have one question. So I asked a few exercises, right? Single dimensional array and the multi-dimensional array. Okay, apart from what Hari told, did anyone have any issues regarding writing code and trying to execute those things? Please let me know. Raise your hand if you have faced any issues, or if you are not at all able to do it, or if you have any questions related to those exercises. Okay. What I will do is, I'll in one of the sessions we will start by taking your example. Okay, one particular example, and we will try to write a program and try to explain what exactly is going in that particular program, whatever it is, maybe two-dimensional array or single-dimensional array, and we will try to go over it. That will give a clear picture on, like, if you are facing any issues, that will give a clear picture on how to go about it. Okay, please let me know if you have any concerns. If you can ask me now, or you can send me an email. Okay. No one has any issues related to the sessions till now. Please don't hesitate, because if we hesitate, we will kind of like get blocked. Okay, so are all of you trying to practice what are we discuss in class? Looks like nobody has any issues. Okay, I take it as a compliment. Okay, yeah, let us start with operators. Okay, so Java provides a rich environment for all operators. Okay, so it has a rich set of operators that we can work on in Java. Okay, they're basically grouped into four groups, that is arithmetic, bitwise, logical, and relational operators. Okay, so we'll get started with the arithmetic operators. As you know, these arithmetic operators we can use to kind of like write mathematical expressions that we normally have in classes, algebra, right? And then these operators must be operated on numeric type. They must be operated on numeric type. Otherwise, you'll see compilation error. Okay, compile time error. So the exception, one exception to this is your char data type. Okay, because char data type is a subset of int data type. Okay, your integers, subset of integers. Okay, there is one difference between these integer types and char types, or numeric types and the char types. We know that one, right? So all numeric types are signed numbers. Okay, they'll have either a positive or negative thing associated to it, or negative unary operator associated to a particular number. You prefix that with the negative sign, right? So, but characters are not signed numbers. They are characters, but there is nothing like signed numbers or something like that. They're always positive numbers. Okay. So let us see what are the arithmetic operators that that are there that are available in Java. Okay. So basic arithmetic operators, we have seen it. Okay. Addition, subtraction, multiplication, division, and modulus operator. Modulus operator is nothing but when you operate on two operands, it will give the remainder of the division. Okay. So that is the modulus operator. And then there is something called as compound assignment operators. Okay. So preferred way, I have mentioned it as preferred way. Whenever such situations where you can use compound assignment operators, right? You try to use the compound assignment operators because they are implemented in an efficient way when compared to the equivalent. Okay. So for example, say here the compound assignment operators for arithmetic are plus equals, minus equals, multiplication equals, division equals, and then the modulus operator equals. Okay. So for example, if you have two variables, int x plus equals y, int so let us take two variables, x and y. Okay. So assume that it's an integer, both are integers. So this is equivalent to x plus equals y is equal to x is equal to x plus y. Okay. This particular statement, x plus equals to y is equal, x is equal to x plus y. Okay. So we prefer this one, this particular. I don't have a pen today. Let me try. Okay. So in these situations, right, whenever you are trying to write x is equal to x plus y, in these situations, this is the preferred way. Okay. This is the preferred way. Why is that the preferred way? Because that is the that these things like these compound assignment operators, right? These compound assignment operators are implemented efficiently than these equivalent types. Okay. In these kinds of situations like x is equal to x plus y situations, right? You try to use this particular way, this particular syntax. Okay. So as we have seen, this is the addition assignment operator, subtraction assignment operator, multiplication assignment operator. Why we call them as assignment operator? We have that equal sign, right? This is nothing but your assignment operator in Java. Okay, this is nothing but your assignment operator in Java. Equals is nothing but your assignment operator in Java, right? So that is why these are called compound assignment operators. This is applicable to, with respect to arithmetic, these are the operators that are available. Okay. Let us move to next slide. Okay. So how what is the syntax for this compound assignment operators? As we have seen, this is the way it looks. In the previous slide we have seen, right? Variable is equal to variable plus operators. It can be either plus or the previous slide. Okay, if you go back to the previous slide, we have seen, right? There is a variable VAR, that is what mentioned in our next slide. VAR equals VAR and plus. This is the operator which I have mentioned it as op. Okay, and then this is the second operator. Okay, so those things are in this format, or they come in this kind of expressions. Okay, var is equal to var of expression. It can be any expression like arithmetic expression. Okay, and that can be converted into var of equals expression. Okay, example is x is equal to x plus y, which can be written as x plus equals y. Okay, apart from these basic arithmetic operators and the compound assignment operators, we have something called as increment and decrement operators. Okay, they are your plus plus operator and minus minus operator. Okay, so these plus plus operators, I mean this increment and decrement operators, you can use it as postfix or prefix. Okay, we will see how that is done. Okay, and it results in some interesting results. Okay, we will see that also. Okay, this is all about your arithmetic operators. Let us take an example and see how we can do, how we can test those things. Okay. We will start with the compound assignment operators. Okay, because we know we might have already done the basic arithmetic operators. That's why I don't want to go to basic arithmetic operators. So we'll start with the compound assignments. Okay, so let me try this one. Okay, so first one we will try arithmetic. These are also called as shorthand operators. Okay, so what I want to do, let us result is equal to 0 or whatever it is. Result is equal to, okay, let us try this way only. X is equal to x plus y. Okay, print y. Okay, print x. Let us see. Let us see what is the result. So we are getting the value of x. Okay, so the same thing can be achieved with this particular expression, the shorthand form. Okay, let x and y. Let us see, x plus equals y. Okay, we got x is 30 is stored in x in the previous execution. Now let us see whether we get the same result. Okay, just to verify whether these things are working properly or not. Okay, yeah, we got the same result. Okay, or we can use this as well and then print here x. Okay, x. Okay, we got that result because 30, x is 30 plus y is 20. So we got the result, right? It is similar to whatever we can write using x is equal to x plus y, right? It is similar to that one. So let us try to do x minus equals y. Try x r equals y, or we can write everything in the same sentence. Okay, let us see what exactly happens. Okay, Yeah, you can see what else we can put it here. Put here is equivalent to x equal to x minus y. Same thing you can put it here. X divided by y. Okay, this one is x plus y. Okay. Yeah, you can see x is equal to x plus y. This is subtracted 20 and 50. So we got 30, and then this one x star y, that is resulting your multiplying x with y, and then since we have not stored x in all these situations, right? In these things we have not stored, the previous value is used. Okay, that is our compound assignment operators. So anyone has any questions regarding the compound assignment operators? Please let me know. Otherwise, we'll move on to increment and decrement operators. Okay, so we'll move on to. Okay, so in increment and decrement operators, we can postfix to an operand, or we can prefix to an operand. Okay, we have two operators, that is increment and decrementers, plus plus and minus minus. Okay, so these things we can use it as postfix to a. These things are unary operators because they operate on single operand. Okay, these are called as unary operators because they operate on single operands. Okay, say for example you have a variable x. Okay, and then after the operand I have attached, or I have used the operand, that is the operator follows the variable. Okay, this is the operator, this is the operand, right? So it is operating on x, but it follows, this operator follows the variable. This is called as postfix. Okay, this is called as postfix. You can also write it as this one. Okay, this is called prefix. Okay, let us see what exactly happens when we try to do both. Okay, let us try to declare another variable int I is equal to 10. Okay, so what exactly happens? Okay, I plus plus. Okay, let us try to print I. Okay, half print, the same thing. So remember, we are doing postfix operation. Okay, that is incrementing. So let us see what is the value. What do you think the value of I will be? Okay, 11. Okay, but let us try to print here. Are you able to notice what is the difference? See here. Let me do one thing. Okay, this is the result. This is the result of whatever I am printing here. Okay, yes, correct, Hari. Yeah, this is the result of whatever is happening. But notice this particular statement. It is very important. Okay, it is very interesting. Okay, yeah, correct, Hari. Yeah, what Hari is saying is for post increment, the print first one. This is the print. Okay, so it uses the value that is already there, and then increments it. That value will be available here. That's what Tari is telling. Yes, sir, exactly correct. So when we are doing what exactly this increment and decrement operator does is, it is similar to x or I. Okay, x is equal to x plus 1 or x is equal to x minus 1. This is what it is doing. It either increments or decrements a variable by 1. Okay, it either increments or decrements a variable by 1. Okay. Okay. So there, what we have done this. We have I mean, we can use that particular increment and decrement operator using either postfix or prefix, which is nothing but your post increment or pre-increment. Okay. Here, what we are doing, it is postfix, which is post increment. We are doing post increment. So when we are doing, yeah, Fanindra is asking a question. Shouldn't it print 11 in the second line itself? Yeah, that is what the Fanindra is asking this particular question. I'm posting it for all your reference. Okay, what he is asking is in the second itself. That is what is interesting thing. Okay, so in the second print itself, okay, it is printing 10. What we were expecting is, we were expecting 11 here, right? So that is what is the difference between post increment and pre increment. Okay, let us try to do this one. Okay, let us try to do this one. Yeah, but are you seeing the difference between this statement and this statement? Are you all seeing the difference between the two statements that which I have told? This is pre-increment. Okay, this is pre-increment. The difference that we see, right? Yeah, Kanindra. Yeah, got it, Kanindra. Yeah. So the difference what we are seeing is during post increment. Okay, the value is, the current value is used, and then that particular value is incremented and assigned to that particular variable. Okay, it is like you use I, the value of the current value of I you used here to print, and then that value is incremented and assigned to the same variable. Okay, because we are doing this thing, x is equal to x plus 1 x minus 1. That is what it does. It increments a variable by 1 and assigns that value to the same variable. Okay. For post increment, the current value is used before the value is incremented. Okay. So once this value is incremented or used, the next value, incremented value, will be available here. Okay. That is why we are seeing 10 here instead of 11. Okay, so Fanindra is telling it is not 100% clear to him. Okay, so what exactly happens here is, okay, let us try to do some other few more things. Okay, let us say we have x, right? X is equal to I plus plus. Okay, and then y is equal to I. Okay, and let us try to print. Okay, here x is 12 because we have incremented the value is 12 here. Okay, and y is 13. Okay, so here what is the value of I here? Value of I is equal to 12 here at this point. Okay, that is before incrementing. Okay, before using this plus plus. Okay, when this particular statement gets executed, what it does is the current value of I, that is 12. Okay, the current value of I, that is 12 will be assigned to X. The current value of I will be used. Okay, the current value of I will be used, and then the operator. Okay, this operator will be applied to this I. Okay, and we'll use the existing value of I to X, assign it to X, and then it is like then you use the increment operator. The value becomes 13. Okay, so that value will be assigned to Y. Incremented value will be assigned to Y. It is like you can split it into these statements. Okay, so what we can do is X is equal to I. Okay, then I is equal to I plus X, I plus 1. Okay, and then the value of I will be assigned to Y. Okay, it is like here you have value of X as 12, right? I mean the value of I as 12, and here you increment it to 13. You increment it by 1, the value will be value of I will, and that value will be assigned to Y. This is your post increment scenario. This is how your post increment works. Just have a look at this particular statement, 3 statements. Okay. Then if you have any questions, let me know. So these 2 statements, right? These 2 statements are similar to this thing. This is how these values get assigned. So what we are doing, so first the value of I will be used, whatever the existing value of I will be used. Okay, that is 12. In this case, that is 12. Okay, that value will be assigned to X. Okay, then this executed, that is I plus plus. Then the value of I will become 13. That value will be used to assign for Y. That is yeah, Phanindra. Do you have any questions, Phanindra? I have unmuted you. You can ask me.
Yeah, the post increment concept, how it is increasing is clear actually.
Okay.
The one thing is haunting me is when we did the print in the print statement, it's like we did print value of I plus plus in
Correct.
the
This one,
so
right?
yeah, that one. So we are
Okay.
actually asking to print I plus plus value. So it should
Correct.
actually do the all the evaluation, like it should add I to 1 and then it should print the output as I plus plus.
Okay.
But why is it printing only I? I understand it's post incrementing. Okay, if you give the brackets, then it will do the increment. Oh, correct. Yeah.
That also it will not do.
Oh,
The
okay.
value of I will be first used. Okay. Whatever the existing value of I, that will be
Okay.
used. This is post, right? We are telling post, right? That is
Yes.
the meaning of post. Okay. You
Yeah.
increment it, post the value is used.
Okay.
You increment it. The operator operates after the value of the variable is used. Okay.
Okay.
Looks like you still have doubt. The value
this,
of I will be incremented after you use it in an expression. Assume that this is an expression. Okay, this is an expression. You are
okay.
incrementing it. You are incrementing it by 1. Value of I is by 1. Okay.
Correct.
So what you are doing here is I is equal to I plus 1. We are doing this, right? So what
Yes.
it does is first this value will be used and then this expression will be evaluated.
Okay.
So
So
first the value of I
while
will be
using
used and
post
then
case, while using post increment, we should always look for the next statement to get it printed.
exactly. It is
Okay.
always like what you need. That is when you decide whether to use post increment or pre increment.
Okay.
Okay. So
Yeah.
if you want to print 11 in this particular statement, which are highlighted, right? Then you can go for pre increment. Okay. So I have showed here,
Okay.
right? So
Okay.
here you need not have to put any brackets here because these have higher precedence than the plus operator here, concatenation operator. Okay.
Okay.
So pre-increment is you use the incremented value itself. First the value of it is like we can say like this. The same thing. Okay. The same thing. What you can do is pre-increment for pre-increment. Okay. So it is like x is equal to first what happens this value I plus 1 value of I will be used.
Okay.
Okay. This here we are using this is arithmetic expression, right? So
Yeah.
first what happens, or we are using this assignment operator. What exactly happens? You use your first the expression will be evaluated after you are using this equals, right? This
Yes.
particular right hand, this is the right hand side, this is the left hand side. Okay. So what happens when in an assignment, first the expression on the right hand side, that is arithmetic expression, will be evaluated and the value of the result will be assigned to your x. Okay.
Yes.
That is what happens with your prefix or
Okay. In that
pre-increment
sense,
of
it
I.
should. In that sense, when we in the print statement, if we use the braces and we put that I plus plus inside the braces, according to precedence, it should actually evaluate the post increment first, and then it should print outside.
Correct. This is for our understanding. Whatever we have done here, right? This
Yeah.
is for our understanding. Okay. This is also for our understanding. But how they have implemented this operator, that actually differs. Use it. Okay. The definition for this particular operator depends on how you use it. Whether you use it as post increment operator or post decrement operator or pre-increment or pre-decrement operator. So
Okay.
whatever
So
we
it's
explained here, right?
exactly. So it's exactly
Yeah.
when we use the I value next time when we use that post increment, then only that value gets reflected. That's what.
Exactly. That is for post increment. For
Yep. Yep.
pre-increment, you can easily get it. For
Yeah.
pre-increment, right? So for here, x is 12 and y is 13, right? Let us try doing
Yeah.
this one.
Okay. While compiling time, only the next statement when it's executing, then only it will evaluate that post increment. Till then, the
Yes.
value of I will be like as it
Yes.
is in the memory.
Exactly.
Okay.
Exactly.
Yeah. Got it.
Okay. Yeah. You can say,
Thank you.
let's just
Thank you.
wait. Sure. Surrender. Fine. Okay. We'll be able to see the difference clearly. So you can see x is 12, 13. Here it became 13 and 14. So this value already first it gets evaluated and then that value will be shown here. That value will be utilized. How that value is utilized, it depends on whether you use it in postfix or use it as postfix or prefix or post increment or decrement or pre-increment or decrement.
Okay.
I hope it is at the beginning, right? You will kind of like get confused with these things, but over a period of time you will understand. But if you still have any doubts, please let me know. I'm not asking Sadindra only. I'm asking everyone. If you have any doubts regarding post and pre-increments, or decrements, please let me know. Okay, looks like everyone is comfortable with the post and pre-increment. So again, I would like to mention like the value will be you use post and pre-increments based on your requirement. Whether you want the value immediately or you want the value after you increment it. Okay, immediately you increment and then you use, if you want to use the existing value currently and then increment and use that value afterwards, then you use post. Otherwise, if you want the value incremented immediately and assigned, or you want to use it immediately, the incremented value immediately, you go for pre-increment operator, increment or decrement, or you use it, you prefix that value to a variable. Okay, so both in postfix, we see that operand follows the operand follows the operand, but in prefix you see that it precedes the operand. Okay, this is this is the operator which follows your operand. The other way, you prefix operator before or the operator precedes for the variable. So that is the difference. Okay. Okay, let us see what are relational operators. Okay, so these operators we have already seen, right? The relational operators in our statement and for statements, that is control statements, right? So these operators are basically used for establishing or determining a relationship between the two the operands of which you are using these relational operators. So they are basically used for checking whether the operands are equal or equality of operands or ordering of operands. Okay, ordering equality is you check whether both the operands are equal or not. Okay, that is your equals operator and not equals operator. Okay, ordering you use greater than or equal to, less than or less than equal to, all those operators. Okay, we'll see in our next slide what are the operators available with respect to relational operators. Okay, so whenever you use these operators, okay, on operands, okay, the result will always be a Boolean value. So the result will always be a Boolean value. So the Boolean values, the two Boolean values that we have is either true or false. Okay, either true or false. So whatever the expression, relational expressions or the expressions that you use with relational operators, right? They always result either true or false. Okay, they always result either true or false, nothing else. Okay, only it results in Boolean values, true or false. So we have seen these things used in conditional statements, right? In our if and for loop. The control statements which we are familiar as of now is if statement and then for statement. In if statement, you have if and then you give a condition whether that particular condition is true or false. There you specify your Boolean expression, which is formed using your Boolean operators. Okay. So while comparing, we compare the equality or inequality of two operands by using either equals operator or not equals operator. Okay. So single equals is, we know that it is a assignment operator. Okay. Single equals is an assignment operator. Equal to. Okay. That is a relational operator which results in Boolean value, either true or false. Say for example, if x is equal to y, okay, what you are doing? If x is equal to y, we are taking two variables, okay? X is equal to y, okay? Here we have two variables, x and y, okay? What we are doing, this particular thing is an assignment. Okay, what it results, if y is equal to 10, the value of x will be 10 because you are assigning 10 to x. Okay, this is assignment operator. But in case of x equals y, this is a Boolean expression or relational expression. Okay, so what it results? It results either true or false. Okay, it either results in true or false. If x is equal to true, if x is equal to y, then it is true. The result will be true. Okay, if x is not equal to y, whether x is less than or greater than y, that is immaterial. The output will be false. Okay, so the output, the result will always be either true or false, which is your Boolean value. Okay, which is your Boolean value. Also, you use some operators like greater than or equal to, less than or equal to for your ordering. For example, you are doing sorting operation, incrementing or decrement sorting operation. Use these operators. You compare these two values, like whether the one value is greater than the other. Is x greater than y, or x is greater than or equal to y? X is less than y, or x is less than or equal to y. That is what you use for ordering. Okay. Either you use these operators for finding out whether the two numbers are equal or unequal, or use which is the greater than or less than. So let us see what are the operators that are available. So we have equal to operator, not equal to operator, okay, and then greater than, less than. So just check this particular thing. Okay, this is not equal to. Exclamatory operator is, when you use exclamatory operator with equals, it is not equal to. Instead of checking whether both the numbers are equal, you are checking whether they are not equal. Okay, so do you see the difference? Like what is the difference between this equal to and not equal to? So if the two numbers are equal, x and y, for example, your here for this equal to, okay. So what you are doing, x equals y, okay. The result will be like, if both are equal, the result will be true, right? Here for this situation, in this case, x is not equal to y, the result will be true only when both of them are not equal to each other. Okay, when x is not equal to y, the result will be true. Okay, when x is not equal to y, the result will be true. Or say for example, if x is 10 and y is 11, they are not equal. Okay, that is why the value will be true. But when x is equal to y, that is if both x and y are 10, then this will be false. So this is the exact opposite of what we are doing here. Okay, what we are doing here. So if it results false for both the numbers, when both the numbers are equal, this results, I mean, if it results true when both the numbers are equal, this results false for the same condition with the same numbers x and y is equal to this one. So let us see that one. Let us take two numbers, x is equal to 10 into y is equal to 20. Okay, let us try to print what is the value of x is equal to y. Okay, what is the value? This is false because x is not equal to y. Okay, then now we'll try x not equal to y. We are checking whether x is not equal to y. So it should result for, true, right? X is not equal to y. Is x not equal to y? Yes, that is true. Right? Because they are not equal. So now what we can do? X is equal to y. Okay. What we can do here? We can do this one. Okay. The same thing. You see the result differently. So this is the difference. This is the difference. This is the second difference. Okay. So here, in first condition, what we have, x is 10 and y is 20. But here, what we are doing, we are assigning y to x. So both are 20, 20 here. So when we ask whether, when we check whether the both are equal, here it results true because now x is equal to 20 and y is equal to 20. But when we check whether they are not equal, it results false because they are equal. Okay. Because they are equal. Okay. So let's move on to the next one. Yeah, please let me know if you have any doubts or questions regarding these things. Okay. Whenever you get any doubt or whenever you have any doubt, please let me know. Okay. Raise your hand. I'll just unmute you. You can ask questions. Okay. Hope everyone can listen to me clearly. I'm assuming like I'm audible. Okay. So okay. Next. Okay. Thanks, Anindra. Thanks for confirming. Yeah. So next we'll move on to logical operators. Okay. We call it as Boolean because the result will always be Boolean. I mean, Boolean logical operators. What exactly these operators operates on is, it operates on Boolean operands. That is, what are Boolean operands? Operands that result in either true or false. So which kind of expressions result in Boolean values? Relational operators with the expressions with relational expressions. The expressions that you use with your relational operators. Okay, they return Boolean values. On Boolean values, you use these logical operators. So let me know if I have confused you all. So from our previous discussion, we saw relational operators, right? So relational operators work on or they result in relational expressions. Okay. So the result of a relational expression is either Boolean, not either true or false, right? That is Boolean value. So they result in Boolean values. Relational expressions result in Boolean values. So these logical operators operate on those Boolean values. Okay. There are different logical operators. AND is there, OR is there, logical OR. This is logical XOR. Okay. We will see what is this logical XOR. This results in one when the operation of this logical XOR is it is exclusive OR. Okay, it is exclusive OR. So exclusive OR means like when the values of say for example you are taking two variables, okay, x and y. Okay, so when the values of x and y are equal, this results in false. Okay, when the values of x and x is not equal to y, that time it results true. This is the simple definition of our XOR. Okay, but in this case, right? Okay. So, do you want me to explain how it works and OR and XOR? How the logic of AND, OR, and XOR works? Let me know. I can explain it. Otherwise, what we can do is I can give a brief discussion on these things when we discuss about bitwise operators. Okay, when we discuss about bitwise operators. If you want it now, I can explain it. That is not this thing. So, say for example, AND. Okay, how AND operates. Say you have A, you have B. I'm just explaining it with respect to the result is your X. Okay, the result is X. I'll take bit by bit. Okay, so I'm talking about the what we call it as the truth table. Okay, we call it as truth table. So that is what I'm just explaining it. So say for example, it is based on your single bit operation 0 or 1. Okay, say for example, X is, this is the expression we write, A dot B. This is how you represent AND. Okay, so that is dot. So say for example, these are single bits. Okay, I'm just stressing that this is these are single bits. So when A is 0 and B is 0, this will be 0. Okay. Okay, and when A is 0, B is 1, this will be 0. Okay, when A is 1, B is 0, this will be 0. When A is 1, B is 1, this will be 1. So in one way, what you can, in Boolean values, okay, in Boolean values, if you want to write the same thing, X, B, A, okay, so this is false, false, okay, the value, the result will be false in case of our logical AND. Okay, let me know if I am confusing you all. Okay, let me know if anyone is getting confused. If anyone is getting confused, please let me know. Okay, this is false, this is true. Okay, the result will be false. Okay, this is true, this is false, this will be false. This is true, and this is true, this will be true. So as you might have understood, AND will operate, or the result of an AND operation, the result of a logical AND operation will be true only when the both operands. Okay, say for example, we are saying, okay, we will see that in an expression, in a program we will see that one. Okay, so AND operates like this. Okay, say for example, you are using A, and this is your sorry. But in Java, yeah, Hari is asking this question. So is the T is equal to T? No, it's F is equal to. No, what is that, Hari? It's T is equal to 1 and F is equal to 1. I did not get that. I thought. Yeah, give me a second. I'll just unmute you. Yeah. Yeah, ask your question, Hari.
No, it's not a question, sir. Actually, for AB values, we take zeros and ones in the first table, And the second truth table you take like a false and truths, right?
Correct.
A
Exactly.
simple way is like a false means like a 0 we have to take, and true means ones.
Yeah. Correct. That is
So,
that will confuse people here, right? So in C, C++, what you can do is like you can use 0, any positive number in C or C++, any positive number is considered as true, and 0 will be considered as your negative number, or 0 will be considered as false. Okay. So in Java it is not like that. Okay. In Java it is not like that. True means it is a Boolean value, true. False means it's a Boolean value, false. 0 and 1 you can't use it as true or false. Okay. So that is why when I put like that, go ahead.
Just like from the above table, if you take like a 0f, 0 as a f, then we can easily understand the bottom table.
Correct. Yeah, that is true. Whatever you told is correct. So here, whatever I have mentioned as 0, I have mentioned it as false, and whatever I have mentioned it as 1, I have mentioned it as true here. That's what you meant, right? Yeah. So that is how usually that's how we work in electronics, right? So
for the AND operator, if both the values are like ones, like both the values are true, then only the output is true. Otherwise, any one is like a false, then total output is like a 0. Like a false, right?
Correct. Exactly. That is correct. That is correct. So that is in case of OR, we will see. Yeah. So that is the bottom line. I don't want to confuse people here. That is why I just used like that. Okay. 0, 0, 1, and false and true. Let us stick to this false, true only. Okay. That will be easier instead of getting confused with the true is equal to 1 and false is equal to 0, because I don't want that confusion for others, because that is not how it works in Java. Okay. So let us stick to true and false. Yeah, sure, Ravi. Okay. So in case of OR, okay, in case of OR, how it works? It works like this one. Or how say x is, the expression will be like this: x is equal to a or B. We will see that in a simple program. Okay, in a simple program we will see that the result will be like this: a, okay, b. The result is your x. Okay. Please let me know if you are getting confused. Okay. So first is our false. Okay, and this will be false. Okay. Then false, true. This will be true. Okay. This is true, false. This will be true. Okay. And then true and true. This will be true. Oh, Panindra is telling, is it okay to think of it as or as plus? You mean to say addition, Panindra? Let me unmute you. Yeah, Panindra, you can go ahead and ask your question.
Yeah, it's nothing. Like we can remember it as OR means if we add addition, or AND means as multiplication. That's what I meant.
So how you can say that one?
It's like if it is OR, one. Suppose like you mentioned before, like zeros and ones. If you consider 0 plus 1 equal to 1. So any one of the value is 1 among A and B, then the result will be 1.
0 plus 0 is 0.
Yeah.
0 plus 1 is 1. 1 plus 0 is
1.
1. 1 plus 1 is, let's say 1 plus 1 is 1.
I mean, some positive value, anything
Yeah,
other than
that's
0.
what. Yeah, that's what. When we try to do these things, right, it usually gets people who are new to these topics, right, they'll
Correct.
easily get
Yeah.
confused. They'll
Yeah,
easily
it's
get
better.
confused.
Yeah,
Okay,
it's better to
better
use
to
true or
stick to
false.
this particular. Yeah, true
Yeah.
or false. We will see those with an expression. Okay, I mean, in a simple program, we will see those things. Okay.
Oh, okay.
And yeah, thanks for bringing that out, Panindra. Okay. So so next we have, these are all logical and or and XOR operations. Okay. The XOR, as I told you, it will result only when the two values A and B are not equal. Okay, and that is in these situations XOR will result true. Okay, only these two things, under these two conditions it will be XOR will be true. For other two conditions, when both are equal, right, then it will be false. That is the XOR condition. Okay, so that is your XOR condition. So your short circuit OR and short circuit AND operators are there. So we will see what are these short circuit OR and short circuit AND are. Okay, and you have logical unary NOT operator. Okay, logical unary NOT operator. So what are the expressions? So whatever we are discussing, we are discussing about Boolean logical operators, right? They work on Boolean values. They don't work on any numeric values or anything. Okay, they work only on Boolean values, either true or false, either true or false. Okay, so when you use this particular unary operator, NOT operator, unary NOT operator, okay, when you use this unary NOT operator, whatever the result of a relational expression, that will get inverted. Say for example, if the value of relational expression is true, this will turn it into false. Okay, as in arithmetic operators we have seen, right, compound assignment operators. Similar to that one, we have compound assignment operators here also, logical compound assignment operators. Okay, so let us take a simple example and explain what exactly is happening. Okay, that way we will understand these things in a better way. Okay. Okay, let us take this one. First, let us take logical AND first. Okay. So as I mentioned, these logical operators work only on Boolean values. Okay, they work only on Boolean values. Say for example, I am checking is x is equal to y. The result will always be Boolean, right? We will use the operator, AND operator. Okay, this is our AND operator. This particular is our AND operator. Okay, okay, x is equal to y. Okay, and what I'm doing, whether x is equal to y, and let us make this as this one, just for change. Okay, I'm checking whether x is equal to y and y is equal to x. Okay, this is false. Why this is false? I am checking is x is equal to y. This is false, right? And I'm again checking y is equal to x. This is also false. So in case of AND, we have seen like if f a x and y, let us consider x and y. if X is false and Y is false, the result will be false. Okay. If X is false, Y is true, the result will be false. Right? If X is true, Y is false, the result will be false. Okay. If X is true, Y is true, then only the result will be true. Okay. So let us check all those things. Okay. This has resulted in okay, X5 is equal to. Okay. Let us take these three things. Okay. So I am checking what is the thing. Result. Just checking. If X is equal to Y. First, let us take this false, false, and let us see whether the result will be false. Okay, and remember these are relational expressions, right? So they result in either true or false. Okay, they result in either true or false. These are relational expressions. They result in either true or false, and this is your logical operator which works on the Boolean values resulted out of your relational expression. Okay, this works on the Boolean values or Boolean expressions resulted out of your relational operators. Okay, this whole thing is a logical expression. Please let me know if you are getting confused. Okay, so we will try to kind of like clarify your doubts here itself. Okay, so even though if you have doubts after the class, when you are trying your own things in your programs, right? If you get any doubts, please let me know. We will try to clarify those things. Okay. So what is this? Is X is equal to Y, and first false, false. Let us try false, false. Okay. Is X is equal to Y and Y is equal to X. This results in false, right? This results in false, both the sides. So assume that this is A. This expression is your A, and this expression is your B. Okay. This is similar to your A and B. Okay, here A is your X is equal to Y, B is your Y is equal to X. Okay, is X is equal to Y? No. 10 and 20 is Y? No. This is false. Okay, this expression results in false. And we will see whether this expression is true or false. This is also false. Okay, in this case, we are seeing this condition. False and false. Okay, let me write this in a better way. A, B, X. Okay. False, 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 true, false, true, false, false, true, true, true. Okay, this is what we are trying to achieve now. Okay, we have seen this particular condition. Okay, so that is X is not equal to Y and Y is not equal to X. That is why 10 is not equal to 20 and 20 is not equal to 10. That is why we are getting false, false in both the expressions, this expression and this expression. So the result will be X, which gets assigned to this particular Boolean value. Okay, that's what we are going to print here. Again, okay, result. Now let us see what happens with this. Now what we are trying to do, A is false, that is our X is equal to Y. It is not true. Now we will see true things. Okay, is y is equal to v, because yes, it is true. Y is equal to 20, v equal to, I mean, y and v are both are equal 20. So let us try to print the result. Okay, let us try this one only. Copy paste it. Are you all getting what I am trying to tell? Please raise your hand if you have any doubts. Okay, please raise your hand. I will try to clarify now only. In the class itself, we will try to clarify. Okay, and then next condition is true and false. Let us make this itself here. True and false. Okay, let us remove this, and then we will see y. Okay, let us see the whole result. Let us comment this particular part. Comment this. Okay, so first is false, 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 true, false, true, false, false, true, true, 0, true, true, true is true. Okay, so yeah, the result is first condition. You have to see this is false, this is false. So the result will be false. Here we can see that. Okay, so let us see. False, false equals false. False, true, true, false, true, true, true. Okay, so just for our reference. Okay, so first condition results in false and false, so the result is false. Second condition is false and true, the result is false. True and false, false, that is why the result is false. True and true, the result should be true, this is true. Okay, similarly we can try for or condition. Okay, let us try the same thing. So this is false, false, the result should be false. This is false and this is true, the result should be true. Okay, false, 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 this is true, this is also true, and this is also true. Okay, this is your logical OR results. Okay, let us execute and see whether okay, where is that okay, so let us separate. Okay, so these are your logical AND results, these are your logical OR results. So when both are false, the result will be false. Okay, when any of the things or both are true, that is when you get the result as true. In this case, only when both are true, you are seeing true. In this case, when both only when both the condition both the relational operands are false, this is false. Okay, let us see in similar way. Let us see the XOR condition. Okay, XOR is this one. If I'm not wrong, okay. The caret, we call it as caret. Okay. Okay. So what happens when both are false? It will be false, and both are true. It will be false. Okay. Otherwise, it will result in, if either of them is, I mean, if the result is different of both expressions, then only it will be true. Okay, true, true. Okay, let us see whether that is results. Okay, so when both are equal, expression A and expression B are equal, it is false. When expression A and expression B are true, this will be false. Okay, if both are not, like either one of them is true or false, this is true. Okay, so now let us take our short circuit logical AND. Okay, so here logical and assignment. Okay, so logical and assignment is nothing but your let us take your compound assignment, and is equal to, similar to say for example, let us take one example, x is equal to x and y. Okay, this is what happens. So this is your x and equal y, where x and y are Boolean values. Say for example, a is equal to B false. Okay, now what I will do, A is equal to A and B. So when I print the value of A, okay, what happens? Okay, so you will see the result as false. So what are we printing here? We are printing the value that is assigned to A after this expression is done. Okay, let us see what is the value of this one. We got the same result, right? So this is similar as we have seen with the arithmetic operators. This is also same, like arithmetic or logical compound assignment operators. Okay, these are all, this work in similar way. Okay, all these things not equal. Okay, okay, we will see not expression. Okay, we have not seen this particular logical unary not, right? Okay, so let us see we know that the value of this particular expression is false. Okay, in some condition, say for example, somewhere you want to check whether this is false or true. Okay, the result is false, but you want to invert that result. Inversion is nothing but here, if the expression is false, it will become true. If the expression is true, it will become false. So let us consider this particular expression. Okay, let us consider this expression not. Okay, let us see this. Not of A ampersand equals B. Okay, not of A ampersand equals B. Let us try to print that value. Okay, so this is true. Here we have false, this became true. Okay, so how to get back the same result? That is the previous result. make this not of A ampersand equals C. Okay, we will get back the same result. This is false. So what is this first not is what first not is doing? It inverts the value of this expression. Okay, what is this doing? This inverts the value of this whole expression, not of A and ampersand equal B. Are you all getting what I'm trying to explain? Or is it too much of explanation? In either case, you can tell me. Okay, I'm just trying to clarify how these things work. Okay, now please raise your hands if you have any questions, any doubts. Okay, so we will consider what are these short circuit and OR operators. Okay, so when you see the difference with short circuit OR and AND operators, you're using the same logical AND and logical OR, but 2 times you are using it. Okay, what is the difference? So what is the difference between this short circuit OR and short circuit AND? Let us go back to one of these expressions. Okay, it is the AND and OR logic is the same thing. So AND and OR logic is same. Okay, AND and OR logic is same. That is, we have seen, right? This is your AND logic. Okay, and we know the OR logic as well, right? We know the OR logic as well. Okay, so we know OR logic. When any one of them is true, between 2 operands, if any one of them is true, the result will be true, and it will be false only when both the operands are false. Okay, exactly opposite of your AND operator. AND operator will be true only when both the operands are true. Okay, or if multiple operands are using, and all the operands are true, then only result for AND will be true. Okay, here the OR will be false only when both the operands or multiple operands are false. Okay, let us take logical AND. Let us take this piece of code. Let us do one thing. Let us do side by side. Just have a bit of patience. Just copy pasting it. Just want to show you how they differ. Okay, and I'll explain what exactly is the difference these two. But the logic is same. Okay, logic is same. I just want to explain how that is same. But where exactly the values are different. Okay, that's what I just wanted to show. What we can do is we can do all things here. Okay. Substitute. Okay. Let us see. Let us analyze the result. Okay. So here we are seeing false, false, false. So remember, we are the result 1. Okay. Sorry, this is result 1. Result 1. Okay. So result 1. Result 1. Okay. So remember, in result 1, the same expression, whatever the expression that we have here at the top, the same expression I've used, but I've used short circuit AND operator here. Okay, I've used short circuit AND operator. So carefully see the result. What exactly is happening? Logical AND. This is your logical AND. This is your short circuit AND. Do you see any difference between these two things? See the result. You can see the result. Do you see any difference? Just say yes or no. Do you see the difference? No. Yeah, Ali told it. There is no difference. But why do we use? I mean, what is the advantage of using this particular short circuit AND operator or short circuit OR operator? Okay. See the result. Okay. So false, false. Okay. This is false. False, true. This is false. True, false. This is false. True, true. This is true. Right. Say for example. So assume that this. Let us separate these results in two parts, two groups. This is one group and this is one group. Okay. This is the explanation for your short circuit and short circuit OR operation. Okay. This is the explanation for circuit and short circuit OR. Okay. So, okay. So let us consider this particular part. Okay. False, false, the result will be false, right? So let us consider this expression. Okay, what Java does when we use this particular operator when compared to this particular operator. Okay, so here see the result: false, false, false. Okay, this is your right hand expression, this is your left hand expression, and this is your operator. Sorry. Okay, this is your operand, this is your operand, this is your operator. Left hand operand, right hand operand. Okay. So when you see this expression, this whole expression, and when you see the expression of this one, then what? See here, if any one of them operand is false, the result will be false. If any one of the operand is false, for AND operation, if any one of the operand is false, the result will be false. Okay, the result will be false. So this short circuit operand, how it works is, it first checks your left hand operand. Okay, it first checks your left hand, and if this is false, this is AND operation. This is false. It means if any one of the condition is, if any one of the operand is false, the result should be false. Okay, it sees this expression. If this is false, first the left hand expression is evaluated, and it checks the operand. Okay, what the Java compiler does or Java interpreter does, checks the operand. If it is false, it is not going to evaluate this expression at all. It is not going to evaluate your right hand expression. It just says it is false. In this case, if this is false and this is false, that means this expression is evaluated and this expression is also evaluated. Okay, in this case, we have only one AND, logical AND. This expression is also evaluated, this expression is also evaluated. Then the result will be assigned to this one, result. But in this case, if this first left-hand expression is evaluated and if it results in false, it is not going to evaluate this particular expression at all, because we are using AND, and if any one of the operands or if both the operands are false, the results will be false. So this particular expression will not be evaluated at all. The right-hand expression will not be evaluated, or to evaluate right-hand expression, the Java decides whether the left-hand expression is true or false based on the operand you use here, operator you use here. Okay. So similarly, if you consider OR operator, right? If you consider OR operator, you can check this one. Yeah. Pawan has a question. Yeah, Pawan.
Yeah, hi. I mean, can you just repeat the difference between a short circuit and a normal? Because there's a problem in the system. I just refreshed it.
Okay, no worries, Pawan. Yeah. Yeah. So here is the operator difference. Okay, we are using 1 ampersand here and we are using 2 ampersands here. So both refer to the same operation, that is your AND operation. Okay, both refers to your AND operation. We know the truth table for AND operation, that is false, 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 true, false, true, false, false, true, true, false. I mean true, 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 right? But the difference lies where. So when you consider this expression, this is your logical AND operation. So here you have two expressions. Okay, you can consider, for example, you can consider these expressions also. X is equal to Y and X is equal to Z and Y is equal to Z. Okay, consider this is a bit complex. We are using 3 operands, right? This one, and this one. Okay, or you can consider this way. So now we are using only, for this operator, we are using only 2 operands, this one and this one, the result of this whole expression. Okay, so what exactly happens with respect to this particular expression? I'm just trying to explain with the complex expression, that's it. Okay, relational expression with Boolean conditions. Okay, so what is happening? Exactly happens? This particular this one will get executed first, because we have parentheses in this. Okay, no parentheses. So this gets executed. The result will be here. Okay, the result of this and the result of this will be used for the result of this one, AND operation. Okay, so what exactly happens? Let us say we are checking whether X is equal to Y for this condition, this one. Okay, whether X is equal to Y. In this particular logical AND operation, this whole expression, whatever the expression you are doing here, right? You have here, right? The whole expression will get evaluated and the final result will be assigned to a respective Boolean variable. Whatever, say for example, you want to assign it to Boolean variable X. Okay, in this case, the whole expression will be evaluated. Okay, in this case, the whole expression will be evaluated. The result will be assigned to X. Okay, let us consider the same thing with this. Okay, so this will get evaluated first because we have put it in parentheses. We will see that one, why we use parentheses here. Okay, so Pawan, are you able to hear me? Whatever I am explaining?
Yeah, I can understand. Yeah, I'm able to hear it.
Okay, so I was able to see 2 Pawan Kumars here. So one.
Oh yeah, actually I was even listening from the phone. So
yeah. Exactly, Pawan. Yeah, maybe that may be the problem. Yeah, that's why I saw you logging off. That's why I just wanted to confirm that one. Okay. Okay. So what we are doing here is, so first this particular expression is evaluated. So how this first expression is evaluated? So we will see what is, I mean, each operator, right? Each operator has two properties associated with it, or two things associated with each operator. One is the precedence. Okay, we will see that in later section. One is the precedence of an operator, and another one is associativity. Okay, precedence tells the priority of an operator. We will see all those things in when we discuss precedence, operator precedence, all those things. Okay, and then the associativity is it tells from which way, from right to left or left to right, that particular operator gets, or the expression resulted out of that particular operator is evaluated. Okay, here what happens is this is left to right. Okay, this is done using left to right associativity. So first this expression is evaluated. Remember, we are considering only this expression here. This is evaluated first because it is inside this parenthesis. Okay, and this parenthesis. Or if you want to say, if you don't want that inner parenthesis, okay, so what happens? The whole expression, this whole expression is considered. Please let me know if I am confusing you. Okay, the whole expression is the associativity for relational operators is left to right. Okay, so that means this will be evaluated first, then this will be evaluated, and this will be evaluated. Left to right means left to right. Okay, for some operators it will be like right to left. Okay, we will see those things. Some operators it will be like right to left. For relational or logical operators it is left to right. Here we are doing relational, so left to right. This will be evaluated from left to right. So first what happens? Remember, I am talking about this one now, or even in this case, if you remove this parenthesis, first this will be evaluated, then this will be evaluated, and this will be evaluated. In this case, all the three expressions will be evaluated. This one, and this one, all the three. Okay, but see the difference with respect to this particular expression. Okay, so first this will be evaluated. So is x less than y? False, right? If is x less than y, false. Java will not bother about this expression at all. Java will not bother about this expression, this whole expression at all. The final result will be determined just by evaluating one expression. The final result will be evaluated just by one expression, because we are using AND operation, and the result of AND is if any of the operands, irrespective of the number of operands, okay, irrespective of the number of operands, if you are using multiple ANDs, right? So you are using multiple ANDs. So if irrespective of any operand, if even one of the operand is false, if one of the operand is false, the result will be false. Okay, the result will be false. So it evaluates the first expression. It won't bother about these expressions at all. Whereas the logical AND, it evaluates all these expressions. First it evaluates this, next it evaluates this, and next it evaluates this. All the things will be kind of like the result of whole expression is assigned to this one. But in this case, only this will be evaluated and the result will be finalized, because one of the operand, right? One of the operand is false, so the whole expression should be false. So this will be false. Did you get it, Pawan?
Yeah, understood it. Yeah, I understood the difference.
Okay. So when you see, right, most of the people use this particular kind of expression. Do you see that? Do you see why that particular expression is? I mean, this kind of expressions are used instead of single AND. Excuse me. Yes, exactly, Panindra. So it is fast, right? It is efficient actually. Here, what exactly? To my question, Fernanda replied yes, fast. Okay. So because here you spend some time in evaluating this one, evaluating this one, evaluating this one, and finally result. Okay. Here we are not spending time on evaluating this at all. We just decide the final result based on one expression. That is faster compared to these expressions, right? So that is why people prefer this one. Okay. So this is the difference between your short circuit and short circuit OR. Short circuit OR also is similar to that one only. So if you see the result of OR, right? If you see the result of OR, okay, this will be false only when both the operands are false, or if all the operands are false. Okay. Here, if all the operands are false, then only the result will be false. Otherwise, the result will be true. This is XOR, sorry. Otherwise, the result will be true. So you can see the result, right? So, for example, let us take one of the expression. Or okay, this is OR, right? This is OR. What it does is, in case of double OR, let me take one example and explain it to you. So let us take this one. Okay. So what it does is, it first tries to, okay, let us put this one double. Okay. It first tries to evaluate this expression. Okay. It is false. That is why it cannot, Java cannot conclude based on only one result in this case. It is false. And it has to check whether the other operand is also false. If it is true, then the result the total result will be different, right? So it cannot decide based on only one expression here. So it will go ahead and evaluate this also. Okay. So here also it is false. Okay. Then only the final result will be false. Okay. Let us consider this one. Okay. Here is x is equal to y, false. It will do this one. Okay. So let us consider this part this way. This is the result 1. This is the result 1. This is your OR. Let us put this one here. Okay. And this one here. Okay. So here y is equal to 20 and z is equal to 20. Okay. What happens here is y is equal to z. Is 20 is equal to 20? That is what I am asking. Okay. Is y is equal to, or is 20 is equal to 20? Yes, true. Okay. If you see here, if any of the operands or both the operands are true, the final result will be true only. So Java need not have to go and evaluate this particular expression at all. So the result is decided already. We have already determined what is the final outcome based on one result. Okay, that is what this logical or short circuit OR does. So any questions regarding these things? Please let me know. Any questions regarding this? Please let me know. Okay. Anyone has any questions? Okay. Okay. Looks like everyone understood whatever I told. Okay, let us move on to the next one. That is what I have explained here in short circuit logical operators. Okay, let's move on to this ternary operator. Okay, this ternary operator is it is not like your any other operator. Okay, it operates on three things, three expressions: expression 1, expression 2, expression 3. Okay, the operator is question mark and then your colon. Okay, question mark and your colon. Okay. Let us see how it works. So first, from left to right, this expression gets evaluated. Okay, left to right. Expression 1 will be evaluated first. Okay, expression 1 will be evaluated first, and then the decision on which expression to evaluate, expression 2 or expression 3, is taken based on the result of expression 1. Okay, what happens? First, expression 1 will be evaluated. Okay, the result of expression 1 decides. The result of expression 1 decides whether to execute expression 2 or whether to execute expression 3. The result of expression 1 will be evaluated, or will be used to decide whether to execute expression 2 or whether to execute expression 3. Okay, if the result of expression 1 is true, if the result of expression 1 is true, result 2, expression 2 will be evaluated. Okay, if the result of expression 1 is false, then expression 3 will be evaluated. Okay, so all these three expressions should result in either true or false, or at least one expression. This expression should be either true or false. This can be anything. Okay, let us see an example. Okay, simple example I will show you. We have, what are the Boolean things we have here? X, Y, Z, and A and B are your Booleans, right? Okay, so let us see a simple expression. Okay, I'll take A, or let us say, or result are also Boolean, right? So let us take, okay, result is equal to and simple expression I'm taking with Boolean values. Okay, true. Okay, then false, colon, true. Let us see the result. Let us see the result. Okay. Okay. Now we will do the same thing with, this is the simplest possible thing. Okay. Okay, it is showing remove this condition. Okay, it is saying dead code. It is saying dead code for this, because this is not at all getting executed. Okay, so this will, here also this particular is saying like this is a dead code. Okay, because this is false, this will get executed. This is true, this will get executed. Okay, so let us try to print it. That is just a warning for us. Sorry. Okay, let us try to print the values. So I'm taking simple example just to make sure, just to make you understand, with simple examples. Okay, I don't want to confuse you all. That's why I'm taking these simple examples. Okay, you will see with one another example. I will use A, B, and result, all those things. Okay, so let us consider this expression. Okay, so expression 1 is true, so the result should be false. We are saying that. Okay, here the result is false. In that case, expression 3 will be evaluated. This will be the result. See here. So are you able to see the difference? Are you able to see the result? This is the result. Okay, you can use some arithmetic expression, or you can use some Boolean expression or relational expressions, whatever it is. Okay, so in this case, true, right? First one is true. That is why x and y are added and the result is returned and it is stored in your integer. Okay, result is stored in your integer result, res. Okay, in this case, this is false. This expression is evaluated and the result is stored in your res result. That is what we are printing here. Okay, so this is how you can use your ternary operator. The syntax for the ternary operator is your this one: expression 1, expression 2, expression 3. Okay, so as I told, how this works, it is similar to your if else condition. Okay, if else condition. So we will see when we in our next session or next to next session, we will cover control statements. Okay, control statements. That is when we will see if else condition, loops, different kinds of loops that we have. We have already seen for, right, for loop. So are there any other loops? So there are a do while loop, and the shortened form of for loops, all those things. Okay, so we'll see those things. This is similar to if else condition. How exactly it works? Expression 1 will be evaluated first. Based on the result of expression 1, either expression 2 or expression 3 is evaluated. If the value of expression 1 is true, expression 2 will be evaluated. Value of expression 1 is false, expression 3 will be evaluated. Okay. Okay. So I think I'll wind up the call now. So let me know. Next class we will see what is operator precedence. Okay. Next class is operator precedence, and then we will see the bitwise operators. Okay, what are the operator precedence and the bitwise operators. Okay, we will see like how negative numbers are stored, how negative numbers are evaluated in Java based on, like, there is something called as 2's complement. Okay, how is the 2's complement is calculated and how the negative value is calculated in Java, because all the numerics are signed in Java, right? It's unsigned numbers in Java. Either it is positive or it has to be negative. Okay, so they are signed. What is the expression 2? What is Uchenna? What is, okay, this is a question which Uchenna is asking. I'm not sure whether I'm telling his name properly. So that is the question. So sorry, it is what, not at. What expression 2? What if expression 2 is true? Well, expression 2 will be evaluated. Yeah, that's what I told you, right? So here, say for example, yeah, this is a question, Uchenna. So what I gave this, right? So when I wrote this statement, compiler clearly told, right? Are you all able to see this? It is underlined, this particular value, with yellow line, if you can call it as yellow line. Okay, this is, it says when you place your cursor on that particular value, right? When you place your cursor on that particular value, it is saying it is a dead code. Okay, Java is saying it is a dead code. So when a particular code is dead, when that particular code is not at all needed, okay, when that particular code is not required at all, that is when you say it is a functionality of your Eclipse. Okay, it says this is you can compile and run this particular example, right? Even with that dead code. So Eclipse is saying this is not at all needed. This is a dead code. Even if it doesn't matter whether you have the true value, whether you have that value true or not. Okay, the result will be false. So how you Eclipse assumes that this is this particular value is a dead code? This is true, right? this is false. So the value true here in this, let me explain. Okay, so this whole expression, right? This whole expression, in this whole expression, Eclipse is saying, or Java Eclipse is saying, this is a dead code. Oh, sorry. Excuse me about my handwriting. This is a dead code. Eclipse is saying this is dead code. Okay. Why this is dead code? Whether it is there or not, okay, it is immaterial. Because this value is true, so it has to execute this one. Okay, it has to execute this one. This value is not at all required. Okay, similarly here, this is dead. This part is dead. Okay, already it is false because it has to execute this particular expression. Okay, so this is not required. This is not at all required. So what we can do in this case, is, okay, remove this part and remove this part. What happens? This is not what I was expecting. Okay, so say some expression A ampersand B. Okay, this is A or B. Okay, this is A. Again, it says it is a dead code. Eclipse is saying it is a dead code. That is not required. Okay, yeah, we have to have both the expressions. Otherwise, as we saw, it shows a compile error. Okay, this is considered as dead code because, or if you want to remove this particular dead code, right, you can do this one. You can have one expression here, A ampersand B or A or B. Because we have put the Boolean values, right, true or false, it was able to recognize that which part is dead code or not. Okay, now what Eclipse or the Java has to do? It has to evaluate this expression to find out which is dead code. It cannot decide which is the dead code in this case. Okay, that is why it is not showing dead code in this. Okay, it is not showing dead code in this. Okay, it has to first evaluate to decide which one to execute. Okay, only after evaluating this one, it can say whether to evaluate this or whether to evaluate this. Okay, it can't, when you run it, then only during runtime only you will be able to, or the interpreter will be able to decide whether which one to execute. That is why we are not seeing the dead code part here. Okay, did you get it? Did I answer your question, Uchana? Okay, he says okay. Okay, so if any questions, right? We will. Okay.
Yes, thank you.
Yeah, sure. So that's what. If you have any other questions, let us up at this time. Okay. So I'll take up any questions that you have. So any questions you have? If you have any questions, please let me know. Otherwise, we'll end up this call. Okay. Okay then. Yeah. Looks like no one has any questions. So let us wind up this session, and we'll meet tomorrow at 8 p.m. CT. Okay, today is Sunday, tomorrow is Monday. So as usual time, that is 8 p.m. CT, we will meet, and at 8:05 CT Central Time, we will start our session. Okay. Yeah, thanks everyone. Thanks for attending. Appreciate that you attended during weekend. Okay, thanks a lot. Have a wonderful weekend. Bye bye.